Isosceles. What's isosceles?
Two sides are not equal.
Two sides are equal. So we'll say two congruent sides. Hopefully you all know what equilateral means.
None of them are
Equal and sides, yes. So we could abbreviate and say 3 congruent sides. How's that? That's kind of a funky congruent thing there, but it should just be a squiggly like that. What do you think an acute triangle is? Well, it could have an acute triangle, and it could have a bigger than a 90-degree triangle too. That would be hard to classify. So it's an acute triangle only if it has what? All three are acute. So 3 acute angles. That's my abbreviation for angles.
So all 3 sides are less than 90 degrees?
Not sides, angles. Be careful.
All 3 angles are
Yes.
Wait, then you have an acute side. Oh, yeah.
No. When you say the word acute, you're talking about angles. Okay? All right, right triangle. What do we say about the angle? 1 right angle. 90 degrees. 1 right angle. Could you have 2 right angles? No. All right. All right, 1 obtuse. What's an obtuse triangle? 1 angle is obtuse. What is that?
The 2 are greater than 90.
Bigger than 90. 1 obtuse angle. So notice all of these are talking about the angles, and these are talking about sides. Okay? Obtuse is greater than 90 degrees. Again, it's terminology. You've got to learn the terminology. It's a lot of words. So hopefully you can guess what equiangular means.
Angles are equal.
Exactly. 3 congruent angles. It would be 60 degrees, yes. All right, this is new maybe. Interior angles, and I'm just going to draw you a picture because it's easier than writing in words. So let's say you have 3 lines that intersect to form a triangle. 3 lines that intersect to form a triangle. So that little triangle is here, right? The interior angles is just these angles on the inside. Interior angles. Okay. Exterior angles. Let's talk about that. So, do the 3 lines again. I know it's kind of tight. All right, so you got 3 lines that intersect to form a triangle. An exterior angle is every angle outside, don't do it yet, every angle outside of the triangle that forms a linear pair with the angle inside the triangle. So let's say I color this in. That forms a linear pair with that interior angle. You see it? This is also an exterior angle because it forms a linear pair with that interior angle. However, this is not. Why is that one not considered an exterior angle? Because it doesn't. Right. So, this angle does form a linear pair. So does this one.
Now, would you write it down as a pair?
No, it's just referring to an exterior angle. So you don't necessarily do all of them. What are you confused with? I'm going to write this over here. They have to form a linear pair with, I'm going to abbreviate with, an interior angle. They have to form a linear pair with an interior angle. 180, yeah. What do you think congruent figures are?
Equal figures.
Yes. Yeah. 2 figures where all the corresponding parts are congruent. I know, I didn't make it. I don't know. Two figures where all the corresponding parts are congruent. What do you think corresponding parts are?
All the sides.
Basically, it's just angles and sides in the same position, shall we say, on two figures. Two or more, it could be more. Angles and sides in the same position on two figures.
And then side.
All right. Classify each angle as acute, right, or obtuse. So you guys do the warm-up real quick. All right, let's use some of this stuff. Triangle ABC has vertices here, classified by its sides and its angles. So the first thing we should probably do is plot the points. Yes? 0, 0, negative 3, 3, over 3, up 3. Okay, I'm going to write the ordered pairs because we would like to say that it looks like an isosceles, correct? I'm going to pause this because I don't want parents to hear me say it. How can we check for sure that it's an isosceles triangle? Are you guys still on the word assume? Get off of it. Okay. Good. It's the only thing you'll remember from geometry, probably. Okay, BC.
I love Thursday.
I'm terrible, I'm terrible. How long is BC?
6 units long.
BC is 6. That's easy. We can count. Now, we have a nice little formula that we can use to figure out how long AC is and AB. What is that formula called? Distance formula. Remember? So AC is equal to the square root of, you subtract the x's, remember, 0 minus a negative 3 squared, plus subtracting the y's, 0 minus 3 squared. Remember the distance formula? Yes. Well, the in-between is a plus. But what happens here? Yeah. So this is 3 squared, which is 9. What's negative 3 squared? So AC is equal to the square root of 18. However, that's not in simplest form, is it? Does 18 have a factor that is a perfect square?
9.
So what's the square root of 9?
3.
Oh, remember we reviewed all that stuff, yes?
Wait, why didn't you separate it?
Well, I just did more than one step at once.
No, why would you separate it into 9 and 9?
This is 3 squared and that's 3 squared. That's why I wrote that there.
No, but for the last step. Oh.
Right? Okay. All right, so I'm guessing some of you can see, well, AB is going to be the same because we have the same numbers, don't we? Basically, we have the same numbers. So we'll just do this. Can you all, I'm just skipping steps. Do you see that? 0 minus 3 is negative 3 squared, so on and so on. It's going to be the same. Square root of 18, which is equal to 3 times the square root of 2. So we have two sides that are the same. What kind of triangle is it?
Isosceles.
Isosceles. This side and this side are congruent. Now, It says classify by its angles. They look like they could be all acute, but perhaps this is a right angle. And this is a real flashback here. How can I decide if it's a right angle? Does anybody know? What am I checking? What'd you say, Matt? Could I check the slope of this line and compare it to the slope of this line? If they are perpendicular, what are their slopes going to look like? So it's real easy. We'll check the slope of AB by counting rise over run, right? 3 over 3, which equals 1. This is the slope. Slope of AB. The slope of AC is rise, which is a positive 3, over a negative 3. Are those two numbers opposite reciprocals of each other?
Yeah.
They are.
So that means that it's.
So they are. It is a what? It's a right triangle. That makes this a right angle. Okay, I want to make sure you all see. If I put this over 1 and flip it and make it negative, it's going to be negative 1. Yes? Okay.
So it's a what?
Negative reciprocal. All right, that's the first page.
How many pages are there?
It goes quicker after this, though, I promise. Okay, turn the page. Now we got some theorems here. Some of them are obvious, some of them are new. So, triangle sum theorem. It just basically says that the angles, the interior angles of the triangle add up to what?
20.
Hopefully you know that by now. Okay, so that's important. Exterior angle theorem. The measure of the exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. That's a lot of stuff. Let's just talk about it. Draw yourself a picture like this. Draw yourself a picture. Put this as a 1 here, and put a 2 in this angle and a 3 in that angle. Which one of those is the exterior angle?
1.
And is 2 or 3 adjacent to 1 at all? Is it next to it? No. So these two are non-adjacent angles to angle 1. So what I can say then is the measure of the exterior angle, the measure of angle 1, is equal to the sum of the measures of the two non-adjacent interior angles. So it's equal to the measure of angle 2 plus the measure of angle 3. That's what that's saying. You see it? Okay. So let's use that to solve this right here. Find x and the remaining angles. This is really the same thing as this, isn't it? Exterior angle, interior non-adjacent angles. Okay, so I can use this theorem to help me solve for x. So the exterior angle is equal to the sum of the two non-adjacent interior angles. Cool? Now we just solve for x using your algebra skills. Subtract x, subtract x. Subtract 6, so you get 2x equals 74. X equals 37. So we're almost done. So that means this angle is 37 degrees, correct? Yes, Mrs. Burgess. Okay. So you have a couple of ways you can go about this. You could add these together and set it equal to 3x plus 6. Could do it that way. You could plug in 37 for x. You could do it that way. Let's just do that. We'll do 3 times 37 plus 6 is 117 degrees. So I know that angle. I know that angle. Am I done?
Yes. No. Please say yes.
Find the remaining angles. Did we miss an angle?
No. Yes.
Yes, we did. We missed that little angle right there. It's a linear pair. Or we could do 180 minus 80 minus 37. You could do different things, yes. 63. Okay, now we're done. All right. Congruence statement.
Do you want the check to be like 37 and 60, 80 add up?
You should, you could, yeah. Okay. All right, congruence statement. Basically, it states that the triangles are congruent. It states that the triangles are congruent. That's what a congruent statement is. Now it's important when you are stating that a triangle is congruent to another triangle that you name the vertices in the same order. So if I name this triangle XYZ, and I'm going to say that it's congruent to this triangle, I have to name it in the same order. Triangle NMP. There will be times when you won't have a picture. You'll just have this. And off of this, if they're in the right order, you can name a whole bunch of congruent parts. Okay, so we'll start with the picture here. Let's start by naming the corresponding congruent parts. So this side, let's say XY is congruent to what? NM. If I didn't have the picture, I could get that right from here. XY is congruent to NM because I know they've been named in the right order. Okay? So then we just keep going all the way around. YZ is congruent to MP. And then we could say XZ is congruent to NP. XZ, NP. Pardon me? If you said XYZ here and then you said MPN, that would not be right. Start with the same vertice and go around in the same direction. Okay? All right. Oh, we could do angles as well. So, angle X is congruent to what? Angle N. Angle Y is congruent to angle M, and I can get that just from the naming. I don't even need the picture. Angle Z is congruent to what? Angle P. All right. In this diagram, they're telling me that ABCD is congruent to FGHK. Remember, the naming is important. I can right away say that I know angle A is congruent to angle F, etc., just from the way it's named. But we have a picture here. Find the value of X. Look at it first. If you need X, what information would you use? Eve.
3x minus 6
Equals 9. These two corresponding parts are equal to each other. So that's what I'm going to use to find X. Sometimes you just have to look at the picture a little bit.
Why? How different?
So that is
Right here and right here.
Why wouldn't you do like 4x plus 2y equals 44?
Because you have two different variables here.
Oh.
Okay, so but here I can find X by itself. Add 6 and X equals 5. Sabina asked a good question. She said, why didn't we just jump right to this? We didn't jump to that because it has two variables in it. It doesn't help us. But now I can find Y because I know X. So I can say 4x plus 2y is equal to what? 44. However, I know X is 5. So 20 minus 44, or 44 minus 20, sorry, and y equals 12. Cool? Oh, look what the next one is. It's a proof. Ooh, a proof with a bow tie. Okay. So we need to prove or show that this triangle is congruent to this triangle. So first what you do is you look at your picture. We already know that all the sides, the corresponding sides are congruent, yes?
Yeah.
We also know about what angle. What do we know here? We know that this angle is congruent to this angle because why?
Because there's the little dashes. Or
Because they're vertical. So just to start, we have to prove that all the sides are congruent and all the angles are congruent. We've already been given that all the sides are congruent, so I'm just going to write them real quick. PT is congruent to RT, given. This was all given in the picture, so I'm not making it up at all. QT, only the girls. Okay, so I know that all the sides are congruent. Cool.
So there we go.
Now I got to write down how the angles are all congruent. So we already talked about this angle right here. We've got to name it with the 3 letters though. Angle PTS is congruent to angle QTR.
Wait, what is that one store? That's Boys R Us.
What?
Boys R Us, TRS, I don't know.
Where are they congruent? What kind of angles are they?
Oh, that's good.
Now I know we're writing this as a list instead of a story, and that's okay for now because we just don't have time. All right, so I still have to prove that these angles are congruent to each other. Take a look here. What did we notice this? What do you notice here?
They're parallel.
Oh, so if I extend these lines, those lines, I have a transversal right here, don't I?
Well, we do.
And I can say that P is congruent to R because of what reason?
Because they're, oh crap.
Alternate interior angles. Exactly. Angle P is congruent to angle R because of alternate interior angles.
Oh my gosh, this is so cool.
Oh wait, almost there.
So is S and Q.
This could be the transversal, correct? And then this is congruent to this for the same reason, alternate interior angles. It's like a puzzle.
I don't like puzzles. With no missing pieces.
So if we had more room and more time, we would write that they are congruent because all the corresponding parts are congruent. Okay? So I'm just going to write all parts are congruent. All parts are congruent. We have another. All right. Third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angle is congruent. It kind of makes sense. It would have to be the case because they all add up to 180. If 2 of the angles in one triangle is congruent to 2 of the angles of the other, the third would be equal. Reflexive property. Reflexive is just like a mirror. It's like when you look in the mirror, you see the same thing. It seems rather obvious, but it's helpful when we get to write proofs. Goodness gracious. Symmetric. I'm going to keep going because I want to give you guys time. Symmetric property. It can be said either way. So this is equal to this, then that is equal to that.
So it's like the addition.
What?
Property in addition.
Yes, 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 exactly. And transitive property we've already talked about. Okay? All right. Find the measure of x, y, x, w. Hey, so we're looking for this angle right here. Some people can visualize this. I have to break the picture apart. I think it's easier. I'm going to draw this triangle over here as best as I can. W, X, Y, W. And then I'm going to draw the other one. I know they're not very alike, but that's okay. And I'm going to mark what I know. I know that W is congruent to Z, and they're both 40 degrees. I know that this X right here is 35 degrees. Right there, you see it? And it's congruent to this Y right here. I know it's confusing because the letters are the same. Oh. I need this angle right here, which is the same as this angle, correct? Do you see it? So how can I get that? Just 180 minus 40 minus 35. Maybe you don't need to split them up. Maybe you can see it without doing that. So 105 degrees. That's my answer. Cool? Almost done, I promise. Okay. In the diagram, what is the measure of DCN? So let's see what we know here. Ready? We know that S and D are congruent, so there's 68. This one's 68 degrees. What other angles do we know are congruent?
Is that R? C,
These two, right?
oh, it's a vertical angle.
Because they're vertical angles. We know that those are congruent. Oh, wait a minute. If these two are congruent and these two are congruent, then according to the third angle theorem, these are congruent.
Or you could just add up 180
You can,
and minus that.
but you don't know. Yeah, you could, but that would be a little more work.
That's okay.
Yeah, so basically, it's got to be 75 degrees. Angle D is congruent to angle S. Angle DNC is congruent to angle RNS. If you write it down and look at it, you'll get it. Vertical angles.
How did these just
And then you can say angle C is congruent to angle R because of the third angle theorem. What? Oh, yeah, thank you. Squiggly. Squiggly. All right, we have another proof which I'm going to go really quickly with. When you are given a bunch of stuff and a drawing, mark up your drawing, always to start a proof. So let's mark up what we know. SV is congruent to RV. Tick mark. TV is congruent to WV. I don't know that they're the same as the other one, so I'm going to use a double tick mark. ST and WR, 3 tick marks. They're congruent. And then they also told me that T is congruent to W, so I'm going to do this. Now, this turns out to be exactly the same as what we just did here. How can I prove that they're congruent? What do I have to do?
vertical angle?
Vertical angles. I have 2 of the angles, then the third must be congruent. Yes? So I'm just going to say write all the givens, which is what you would do. But we're not going to write them. Write all the givens. And then you could say angle TVS is congruent to angle WVR because of vertical angles. Therefore, I can say that angle STV is congruent to angle VWR by the third angle theorem.
So the first and second, when they wrote down, like they're different because
Wait a minute.
the
Is that right? No, that's not right, is it? I have the wrong letters here.
It's not good.
T's, you get what I'm saying.
Yeah.
TSV and WRV. I had the wrong letters. And then we can just say all corresponding parts are congruent. So triangle STV is congruent to triangle RWV by the definition of congruent triangles. That's the longest video I